what we're going to look at in a very short section on this 1.6 is a few identities. That song was called All Thumbs from the great Chet Atkins. Do a little research on him if you want to find about an amazing guitar player. All right, so what we're going to look at is what we call the fundamental identity to start with. And just to begin with, I'll kind of give you an idea where this thing comes from. And we're going to do a little proof of this. So we call this the fundamental identity. Sometimes I call this the Pythagorean identity. And the Pythagorean identity basically is derived from the Pythagorean theorem. So what we have is we have sine squared alpha plus cosine squared alpha equals 1. So I'm going to go ahead and just do a little proof of this. So we need a couple of very simple facts that we know something about. First thing that we need to know about is the sine is y over r. The cosine is x over r. And we actually know the Pythagorean theorem, r squared equals x squared plus y squared. So if you did the square root of both sides, you would get that r is equal to the square root of x squared plus y squared. All right, so here's how we're going to do our proof of this. We're going to do quite a few proofs in trigonometry. The higher you get in math and your studies, the more that you learn about proofs. So I'm going to start by having you just write down sine squared alpha plus cosine squared alpha. And what we're going to do is we're going to just replace that. The sine is y over r. So if we do sine squared of alpha, we're doing y over r, then we're squaring it. Then we do the cosine. That's x over r, and then we're going to square that. Now what we're going to do is just work out the algebraic details to this. So if I do y over r times square, that just means I'm multiplying it by itself. So that is going to be y squared over r squared. Okay. Then if I do x over r squared, I'm going to get x squared over r squared. Right, now a couple of simple things. I got a common denominator already, so I just keep the denominator. And I do y squared plus x squared, like that. Okay? Well, one of the things that you'll notice on this is, what is y squared plus x squared? Well, y squared plus x squared is equal to r squared. So what we're going to do is we're going to do just kind of a simple substitution then. So then what we'd end up having is, since x squared plus y squared is r squared, we'd have r squared over r squared. So that's equal to 1. And that's what it's supposed to be equal to. So I just proved to you that the sine squared of alpha plus cosine squared of alpha equals 1. Now we haven't seen this very much yet, but if I write the sine squared of alpha, that just is the same thing as the sine of alpha multiplied by itself. That's the way we write that in trigonometry. Okay, now moving on, I'm going to show you how to use this identity to, if I give you like a cosine or if I give you a sine, you can use this identity to find the other trig function. So what we're going to do on this one is, I basically have given you the value of the cosine, and I've given you that alpha is in quadrant 4. This doesn't really have much bearing on this problem, but I want to just remind you that if I've given you the cosine as 8 over 9, that means I've really given you that x is 8, and I've given you that r is 9. Now we could go about finding this the way we had learned in the past. So what I'm going to do is I'm going to do this like this. I'm going to do this problem actually in 2 ways. So what we have is the Pythagorean identity that we learned. We have r squared is equal to x squared plus y squared. So I'm just going to plug in what we have. We've got, the problem gave you that r is 9. The problem also gave you that x is 8. Now let's go ahead and solve this equation for y squared. So that's going to be 81 equals 64 plus y squared. So now I'm going to subtract 64 from both sides of the equation to get this. And let's see, that would be 15 is equal to y squared. And then if we do the square root of both sides, we get plus or minus the square root of 15. Now the thing that was given in this is you're given quadrant 4. So if you're in quadrant 4, you know that it does that all the time if I press that button. So let me erase that again. And so what I want to show you is what we would get from that piece of information. So basically what we have is we're in quadrant 4. And if we're in quadrant 4, x is positive and y is negative. So that means that y is going to be negative square root of 15 for that reason. And then x was given as positive 8 like that. Okay, so now what we want to do is the problem said we wanted to find the sine of alpha. So if we find the sine of alpha, we know that that's y over r. So we just found that y was negative square root of 15. And we were given that r is 9. So that would be the solution of the problem. So that is one way to do that problem. There is a second way to do this problem. And you can do this like this. You can actually use this fundamental or Pythagorean identity. So what I'm going to do is write down this identity. We have sine squared alpha plus cosine squared alpha is equal to 1. Okay, now I gave you that the cosine is 8/9. So I'm just going to write sine squared alpha plus 8/9 squared is equal to 1. Okay, that's going to leave you with sine squared alpha plus 64 over 81 equals 1. Now I can subtract that from both sides to get sine of alpha equals 1 minus 64 over 81. Okay, I can get a common denominator, and I can write that as sine squared alpha equals 81 over 81 minus 64 over 81. And I'll move this up here. So now I have sine squared alpha is equal to 15 over 81. Okay. Now what I can do is I can do the square root of both sides. Okay, so I've got the sine alpha technically at this stage is equal to plus or minus. And I can do the square root of the numerator and the square root of the denominator separately to get sine of alpha equals plus or minus square root of 15 over 9. But again, since we're in quadrant 4, that means that y is negative, so that means the answer to the problem would be negative square root of 15 over 9. So you can get the same answer regardless of which way you do that then. Okay? All right, now I'll move on to this next page, and we're going to go ahead and take a look at another one like that. Now this time I'm just going to do this a little bit differently, so it doesn't really matter. I'm not going to really worry so much about any of this stuff because it doesn't matter. So if I want to find the sine, and if I give you the cosine, well, we can just use the identity. So now I'm just going to write down sine squared alpha plus cosine squared alpha is equal to 1. Okay, notice that I gave you that the cosine of alpha is 2/5, so it plugs in like that. So you're going to have sine squared alpha plus 2/5 squared equals 1. Okay, so that's going to give sine squared alpha plus 4 over 25 when I square that. That's equal to 1. Okay, now I can subtract that from both sides to get sine squared alpha equals 1 minus 4 over 25. Okay, then I can move this over here. Now I have sine squared alpha is equal to 25 over 25 minus 4 over 25. So that's going to give sine squared alpha equals 21 over 25. And then I can take the square root of both sides. Okay, and again, when I do the square root of both sides, you have that plus or minus. So at this stage in the problem, I have sine squared alpha equals plus or minus square root of 21 over 5, because the square root of 25 is 5. Okay, well, this gave us a thing here. Okay, that tells you that I'm telling you that the sign's positive. So that means the answer to this problem is positive. So our final answer would be square root of 21 over 5, because I actually told you in the directions to the problem what the sign was equal to. Okay, so you can do that fundamental identity if you're given the sine or cosine, then you can figure out the other one. Okay, so I'm going to let you try the next one, this number 3. And again, when you try this, you don't really have to do that stuff if you don't want to. You can just kind of work with it this way, because this is what you're trying to learn, is how to use this fundamental identity. You can also, if you want to try to do it the other way, you certainly can. Basically, in this problem, you'd be given that y is 5, and you'd be given that r is 7. Then you could find x by the Pythagorean theorem, and I'm going to go ahead and just let you do it this way. So I'm going to basically just pause this recording for a minute here and let you try that, and then as soon as you're ready, you can resume and see if you got a good answer. All right, well, let's see kind of how we did on this now. This time, actually, we're going to find the cosine, it looks like. So looks like this time I gave you what the sine is. So that's going to plug in there. So I'm going to have 5 over 7 to the second plus cosine squared alpha is equal to 1. So that's going to be 25 over 49 plus cosine squared alpha equals 1. And then I'm going to isolate the cosine squared alpha so I can subtract 25 49ths from both sides. Okay, and I'll just move this over here. So now I'm going to get cosine squared alpha equals 49 over 49 minus 25 over 49. So I'm getting a common denominator. So that's going to be cosine squared alpha equals, and let's see, 9 minus 5, what's that going to be? 49 minus 25 is going to be 24. So I get 24 out of 49 like that. All right, now what I need to do is do the square root of both sides. Got to remember that you create a plus minus when you do that. So you'd have cosine alpha equals plus or minus square root of 24 over 7, since we can do the square root of 49. Now, if you look at the problem, one of the things that I gave you on this problem is it looks like I gave you that the cosine was negative. So we're going to use that as a part of the problem. So what we're going to end up getting then is negative square root of 24 over 7. However, you can break this up, and this is one of the things you got to do with radicals. You can break 24 up into 4 times 6. And you do that because the square root of 4 comes out to be just 2. So you would end up having an answer of negative 2 times the square root of 6, and then all over 7 like that. So that is the solution of the problem. So actually doing that identity is a pretty slick way to find the other trig function if you know either the sine or cosine. All right, well, let's move on. And next thing we're going to talk about is what we mean by the idea of a reference angle. And there's a couple of things that you might want to write down about reference angles that are pretty important to pay attention to. First of all, a reference angle is an acute angle, and its initial side is always going to be on the x-axis. So an acute angle just means that the answer to a reference angle is going to be between 0 and 90 degrees. Okay, so you're never going to have a negative reference angle. You're never going to have a reference angle that's bigger than 90. Okay, so what I want to do is just kind of show you what they look like in each of these quadrants then. Okay, so let's go to quadrant 1. And of course, what we would do in quadrant 1 is we basically just draw a ray out like that. And then when we're doing a reference angle, we're always drawing down to the x-axis at a right angle, and that angle alpha right there would be the reference angle. So if you're given a quadrant 1 angle, then the answer is the reference angle. Okay. If you're in quadrant 2, again, we always start in standard position from the positive x-axis. So if we drew an angle like that, okay, that would be angle alpha. But the reference angle, what you do is you draw straight down to the x-axis, and then I'll call that alpha prime, and that alpha prime is going to represent that reference angle right there. So again, what you're doing on this is you're always looking at, when you're looking at a reference angle, you're looking at the x-axis and you're looking at that terminating ray like that. Okay, always x-axis and then that radius like that, and that'll give you that idea like that. So the idea would be on a reference angle in quadrant 2. So say for instance that you had a let's say that you had a 160 degree angle. Well, the reference angle would go like this. Okay, you would draw out a 160 degree angle, which would go something like that. So then you're finding that reference angle alpha prime. So it's halfway around the circle minus the 160, you'd be left with 20 degrees. So that would be a 20 degree reference angle right there. And again, on this reference angle, you're measuring between the x-axis and the radius like that. So it's an acute angle when you do that. Okay. All right. Now let's look at what would happen if you're in quadrant 3. So if you have a quadrant 3 angle, it's going to look basically like this. Let's draw a counterclockwise angle down somewhere in that quadrant like that. Okay. So again, what you do is you draw this time to the x-axis. You always are drawing to the x-axis. And then this angle right here is your alpha prime. So it's an acute angle. So again, if you're in quadrant 3, you would be measuring between the x-axis and the radius like that. So you'd be looking basically at this reference angle right in there. That's that acute angle right there. Okay. So for instance, if you had a, say you had a, I didn't want to do that. Say that you had a, let's say a 210 degree angle. Okay, so if we have a 210 degree angle, that a quadrant 3 angle, it would go like this. What you would do is you would draw your angle like that, and then what you'd be looking for is you'd be looking at this angle right in there. So that would be 210 less halfway around the circle would give a reference angle of 30 degrees. So what you're doing is you take the angle I give you and you subtract 180 degrees like that. Okay. Right now, if you're in quadrant 4, it goes like this. So you're going to go counterclockwise, and let's just terminate that angle somewhere in quadrant 4. So that would be your radius. And again, what you're doing is you're drawing to the x-axis at a right angle. And then this alpha prime would be your angle like that. So for instance, if you had a 300 degree angle, that's a quadrant 4 angle, then you would start there, you would terminate in this quadrant, and then if you drew your reference angle at a right angle, you'd be looking at that angle. So what you do is you do 360 minus the angle I give you. So 360 minus the 300 is going to give a 60 degree reference angle like that. So again, the key thing is kind of to look at what these reference angles are talking about. So if you're in quadrant 4, you're looking at the x-axis and you're looking at the radius, okay, like that. So we're always looking at the x-axis as part of that reference angle and then the radius like that. So it's always an acute angle. Okay, so let's do some work with this for a few minutes. And what I'm going to do on this one, first of all, is I'm going to just draw a coordinate system. Oh, that's not what I meant to do. Let's try that again. All right, if we were to go through and draw a coordinates, that is definitely not what I meant to do. I'm still learning how to do Camtasia. It's a little frustrating at times. Okay, so let's try it like this. Let's do us axis. Well, that's kind of cool. That is slick. Okay, look at that. All right, so let's go ahead. When we're doing this now, let's go ahead and convert this to degrees. So we have a pi over 3 radian angle. We know that pi is 180 degrees. So 180 over 3 would be 60 degrees. Okay, so we have a 60 degree reference angle, and that means that we're in quadrant 1. So basically the way that this would work out would be like this. if I went through and drew a 60-degree angle, okay, well, that reference angle is going to be that quadrant 1 angle. Okay, so notice that what you're going to have is that's your angle alpha, which is 60 degrees. Okay, so that would be a 60-degree reference angle. And again, what I was showing you earlier is basically the reference angle is always measuring between the x-axis and the radius, like that. So if I give you a quadrant 1 angle, the reference angle is the same angle. Okay. All right, now let's go to the next one. And let's take a look at how this goes. Okay, so let me go ahead and let's draw a coordinate system here. That is so cool. Man, technology is awesome when it works. All right, so let's go ahead and let's convert this thing over. Okay, so we have negative 5 pi over 4. Let's figure out where our degrees are. So we have negative 5 times 180 degrees over 4. 180 over 4 is 45. Then if we do negative 5 and multiply that by 45, you're going to end up getting negative 225 degrees. So we need to figure out what quadrant we're in order to figure out this reference angle. Okay, so what we're going to have, basically, if you go through and draw this out, it's a negative angle, so we know that we're going to measure clockwise. So that would be, come on, stop that crap. Okay, so what we're going to do is we're going to go negative 90, negative 180, and then we're going to be a little more. So we're going to end up being in quadrant 2, like that. So that terminating ray is going to be right there. Okay, so our job, when we find this reference angle, what we end up doing is we do this basically. So what we're going to do is just go draw straight down to the x-axis like that. You always do that. And then we're looking at this angle right in there. Okay, so the way you're going to do that, and you just got to reason out how you're going to do that then, is, okay, if you went from there to there is negative 180, and if from there to there is negative 225, it's just how much further did you go? Okay, so, and the thing is, you don't have to worry about the fact that they're negative. If you just take 225 minus 180, you're going to have a 45-degree reference angle. Remember, 45 reference angles are always positive. So you can just kind of reason that out. You don't worry about the sign. So what you have is you have a 45-degree reference angle right there. And again, what I've been trying to emphasize is your reference angle is always between the x-axis and whatever radius you're looking at, like that. Okay? All right, next problem looks like it'd be just about the same. It's going to be in a different quadrant, though. So let's go ahead and crunch that out. So if I do that, if I draw a graph on this, okay, basically what I'm going to have is, let's go ahead and just plot that out. So what you're going to have in this quadrant then is going to be a counterclockwise angle. Okay, let me find my pen. There we are. Okay, so we're going to just kind of count it out. So that's like 90 degrees, 180 degrees, a little bit less than 270. So clearly you're going to be in quadrant 3. And again, what you always do is you draw to the x-axis at a right angle, and your reference angle is going to occur right there. So that's what we're trying to do, is find that reference angle there. So the way that we would crunch this out is it would be 225 degrees less halfway around the circle would again be a 45-degree reference angle, like that. So that reference angle is 45 degrees. And again, notice that what we're doing on this is when we're doing this reference angle, again, we are looking at the x-axis and we're looking at the radius. Okay, so it's always an acute angle like that. So that's how you do that. Okay, let's look at one more, just kind of try to look at every situation and every quadrant. So what I'll do on this again is let's draw a coordinate system so we can kind of get a good understanding of where it falls in here. And then what we want to do is we want to go ahead and convert this. So we have 5 pi over 3 is equal to 5 times 180 over 3. Okay, you can reduce that fraction. 180 over 3 is 60. So you get 5 times 60 degrees. So that means you would get a 300-degree angle, which would be in quadrant 4. Okay, so what I'm going to do on that is, we're going to sketch that out. So we know that we're going to be somewhere in quadrant 4. So if I go through on this and just draw this ray, I would be somewhere kind of down in quadrant 4 like that. And then what you're basically doing on this is, again, you always draw to the x-axis. Don't ever draw to the y-axis, and you do that at a right angle, and then you're going to be looking at that reference angle right there. So it's an angle between 0 and 90, so that means you would go all the way around the circle, less the 300 would give you 60 degrees left over. So you've got a 60-degree reference angle right there. Okay, just reason out what you do. And again, what we're stressing on this is look at the x-axis, look at the radius, okay? Those are the things that make up that reference angle, so it's always an acute angle. Okay, so let's see. Now let's look at reference angles for trig values for a few minutes. So what we're going to do is we're going to look at the sine of 405 degrees, and then we're going to reason out what that value is based on the reference angle. So here's the idea. I'm going to go ahead and we're going to draw a coordinate system out on this. And we're going to just kind of locate where that angle is going to be. All right, so first of all, if you went through and did a little bit of arithmetic on this, of course what you would have is, you know that it's more than one lap around the circle. So if you subtracted off 360 degrees, you get 45 degrees left over. So what's really happening on this problem is you're going one complete lap, which is 360, plus 45 more, which is going to put you in quadrant 1. So then I can draw that radius out like that. And then again, for my reference angle, I draw straight down to the x-axis. And that reference angle is going to be 45 degrees. So it turns out, the way it works with trigonometric functions, the sine of 405 degrees is exactly the same as the sine of 45 because they have the same terminating point, see? All right, so what we have then, if we kind of put this together now, is we have a reference angle of 45 degrees. The sine's definition is y over r. The quadrant we're in is quadrant 1, and then we know that everything is positive in quadrant 1. So we know we're going to get a positive answer. So basically what we would do here then is we need to just pull out our triangle, basically. So what we know is we have a 45-45 right triangle, and the sides go 1, 1, square root of 2, with the 1 being the y value, and the r being the square root of 2, and then the x being the 1. So then if we're doing the sine of 405 degrees, well, that's really the same as the sine of 45 degrees, and that's just going to be y over r. So if we look at our diagram, we've got 1 over the square root of 2, and then, of course, we can rationalize that denominator, so we'd get a final answer of square root of 2 over 2, like that. Okay, so that's how you use a reference angle to find the exact value of a trig function like that. Okay, all right, now let's move on and let's look at the next one. So we got square root of 2 over 2 for the last one. Now let's go on to tangent of 5 pi over 4. Okay, well, let's go ahead and let's draw a coordinate system again, and just sketch a coordinate system. And one of the things that we probably want to do on this as we're doing this is we probably would like to go ahead and take that 5 pi over 4 and just convert that to degrees, because that'll help us determine where it is. So that's 5 times 180 over 4. So that's 45. So 5 times 45 is going to be 225 degrees. So that means that we're in quadrant 3. Now we need to find what that reference angle is then. Okay, so if we were to go through and sketch out this angle, it's quadrant 3. So if you count it out, okay, that's 90 degrees, 180 degrees. So you're going to be somewhere over in this quadrant like this. So I'll just go ahead and draw that radius like that. So when we do the reference angle again, we go straight to the x-axis. Then we're looking for this angle right in there. Okay, so what we do is we do 225 minus 180 to get 45 degrees left over. So we have a 45 degree reference angle. Okay. Now what we're doing is the definition of the tangents, y over x. The other thing that we learned is the tangent's positive in quadrant 3. There are several ways to look at that. One thing is the tangent's y over x. In this quadrant, if you're in quadrant 3, x is negative and y is negative, so you have a negative over a negative, so you get a positive. So we're going to get a positive value like that. Okay, well let me draw my triangle a little clearer here. I didn't mean to erase my axis. So let me go through and let's put this together again here. And we need to just pull out our special triangle like that. Okay, so what we just figured out is that we're in quadrant 3. So let's draw a picture of that again. So what we end up having is, on here, we're in this quadrant, so it's going like that. And then we have an angle that kind of comes out like that, drawn straight up to the x-axis. So what we found is we have a 45, 45 right triangle. So the sides go 1, 1, square root of 2. And then really what this would represent is that's x, and that's negative. This is y, that's negative. And then that's r like that. Okay, so what we'd have then on this problem is we kind of conclude that the tangent of 5 pi over 4 is the same as the tangent of 225, and that's going to be the same as the tangent of 45. Okay, and that's going to be y over x. So y is negative 1, x is negative 1, so we get negative 1 over negative 1. Therefore, the answer to that problem is positive 1. So therefore, we get the tangent of 5 pi over 4 is equal to 1. Okay? Okay, so I would like to have you all try number 10 if you would. So let's just pause this for a few minutes and see what you get. All right, so let's go ahead. Let me put a coordinate system on here. All right, so I got that. Now let's go ahead while we're at it. And let's convert this. So we got 4 pi over 3. We need to go ahead and convert that to degrees. So that's 4 times 180 over 3. 180 over 3 is 60. So that's going to be 240 degrees. So we're looking at a 240 degree angle, which of course is in quadrant 3. And again, now we're not doing a tangent, we're doing a cosecant, so I obviously typed that wrong. Okay, so the definition of the cosecant of alpha is going to be r over y. And one of the things we learned was this basically, if you're in quadrant 3, which we are, you have r over y. Well, remember we said r is always positive, y is negative in this quadrant, so you're going to get a negative answer to this problem. So without a doubt, it's negative because we're in quadrant 3. Okay, so now if we go through and sketch out our reference angle, like this. Okay, we're going to start here and, come on, where's my dot? There it is. Okay, so we're going to go like that. It's 90, 180. So you're down in this quadrant like this. Okay, what we're going to do is draw straight up to the x-axis. And then we're going to find this reference angle, which is right in here. Okay, all right. So if I do that reference angle, oh, come on, stop this. That reference angle can be found by subtracting 240 minus 180. Okay, so we're going to go ahead and do that. We're going to take 240 minus 180, that's going to leave us with a 60-degree reference angle, okay? And that, notice that goes along with a special angle. So that's 60 degrees. That means this is a 30-60 right triangle. The sides go like this. The 1 goes opposite the 30. Square root of 3 goes opposite the 60, and that's a 2. However, watch your signs. X is -1. Y is negative square root of 3. And then R is always positive since it's a radius like that. So what we'd end up having then is if we do the cosecant of 240 degrees, really, okay, what we're going to do is we're going to do R over Y. So R is 2. Y is negative square root of 3. So we're going to get a negative answer. Then if we just rationalize the denominator, we're going to get 2 radical 3 over negative 3. And since it's a negative answer, the best way to write that is directly in front of the fraction bar, like that. And that would be your answer to your problem. Okay, so that's what you should have got. All right, so that's how reference angles work. Okay, now we're going to look at a couple of properties of reference angles. This is actually a pretty simple thing to determine, to show on a calculator. So what all this stuff right here is saying is, if theta is the angle I give you, and if theta prime is the reference angle, then you should get the same value, but you could be off by a negative. So here's kind of an example. Like if you had, say for instance, you had the sine of 362 degrees. Okay, well the reference angle, and I'm trying to make this so you can do this in your head, you're just a tad bit bigger than 1 lap around the circle, so you actually have a 2-degree reference angle. So the sine of 362 and the sine of 2 are going to be the same. So this is really saying, if you take a trig function of an angle and its reference angle, you should either get the same answer or you might be off by a negative. So I'm going to display this calculator, and I'll just show you a couple of things on this that'll help you understand this, I think. So I'm going to put myself in degree mode on this. So for instance, if I did the sine of, let's say 300, I'm going to try to make this easy, 365 degrees, that'll give that. Now a reference angle on that would be 5 degrees. So if I did the sine of 5 degrees, notice that I get exactly the same answer, okay? If I did, let's say I did the sine of, let's say we do the sine of 30 degrees, like this, and then so we do that. Now let's say we do the sine of 330 degrees. Okay, you would end up having a negative answer. Now what I was trying to show you on that basically is what's going on with that. On that example I just did, this is what's going on. So if you had a 30-degree reference angle, like this, okay, you'd end up having the 30-60 triangle, so it would go 1, square root of 3, and 2, like that. So basically the sine of 30 degrees would be equal to y over r, so that would be 1/2, or 0.5 is what the calculator just gave us. Now if I did the sine of 330 degrees, okay, well here's what's going on that. Okay, you're in quadrant 4, like that. So you would have this kind of situation. You would have a 30-degree reference angle again, so that matches with that. The sides would go 1, 2, square root of 3. Okay, x is negative root 3, but now y is really going to be a negative value. So if you do the sine of 330 degrees, it's y over r again, but notice this time it's negative 1 over 2, or negative 0.5. So what the calculator just showed you is 30 degrees and 330 degrees have equal reference angles, but since they're in different quadrants, that's why the sine turned out to have the same numerical value, but a different sign. Okay, so that's what I was trying to show you on that calculator. Right, so a couple other ones. Okay, if you did the cosine, say for instance you did the cosine of, let's say 359 degrees. Okay, but what if you did the cosine of 1 degree? because that's the reference angle for that. It's the same, okay? If you did, say you did the tangent of 359 degrees, and then you did the tangent of 1 degree, well, they're different sines, and that's because they're in different quadrants, and the tangent is different in different quadrants, okay? What happened on that problem that I just did is the tangent is positive in quadrant 1, so the tangent of 1 degree is positive, and then 359 degrees is a quadrant 4 angle, so the tangent's negative there. So you can kind of explore this on your calculator, and you can kind of get a better idea of what these statements are saying. Okay, a couple of things that we've already looked at that I wanted to just kind of reiterate here. You need to have some kind of strategy for figuring out the trig functions. Now, the easy thing to remember is every trig function is positive in quadrant 1. And then if you go to quadrant 2, the sine and the cosecant are positive, but everything else is negative. And then if you go to quadrant 3, the T stands for teachers, so it's the tangent and cotangent that are positive, everything else is negative. And then the crazy stands for cosine, so it goes like that. So this is a statement I've seen before: all science teachers crazy. Please don't tell your science teachers I'm teaching you this, though, because they'll get mad at me. But you can use this as a way to remember this then. Okay, you can also remember all students take calculus. Okay, I even heard one time all strippers take cash. You can try that one if you want to. But the idea on this is you just need to find something, some way to remember this. Okay, you can also do this. This is the best way to do this, and this is what I think students really ought to know, is the sine and cosecant have a definition that involves y in it. So y is above the x-axis in quadrants 1 and 2. So you would find that the sine and cosecant would be positive in quadrants 1 and quadrants 2. Okay? And then the cosine kind of goes like this. The cosine and secant are positive when x is to the right of the y-axis. So that would be like this. And then the tangent is when they have the same sign. So in quadrant 1, x and y are both positive, but in quadrant 3, both x and y are negative, so you get a positive tangent like that. So that's kind of the way I like to look at this, is like this, and I think it's, I mean, you can remember those statements if you want to. That's kind of like a trick. It's kind of like a trick, and it doesn't really, prove to me that you're really understanding this. But probably the most superior way to look at this and understand this is like this. So let me try to show you what I'm talking about. So if you looked at the sine of alpha, okay, its definition is y over r. So the question is, where is y positive? Well, y is positive up there and up there. Y is negative there and there. Okay, so that's how the sine would go, like that. I'll try to color code this and be high tech here. So now let's go to the cosine. Okay, so if I did the cosine of alpha, that definition is x over r. So the question is, where is x positive? Well, x is positive in quadrant 1, and it's positive in quadrant 2, like that, okay? And then it would be negative, x would be negative in those two places like that, okay? All right, and then if you looked at the tangent, so let's see if I got another color for the tangent here. If I did the tangent of alpha, that's y over x. So the tangent's going to be positive in quadrant 1 because everything is, but it's also going to be positive in quadrant 3 because you have a negative y and a negative x, like that. And then it's going to be negative there and there, like that. So if you just think about the definitions, then that can help you to figure that stuff out. Okay, so what we again had was everything there, and then it's, the science teachers. Okay, well, that stands for the sign being positive. Then over here, it's all science teachers, so that's the tangent. Okay, the tangent's positive in this quadrant, and then crazy would be the cosine. Okay, like that. Okay, so that's how that works. Okay, so just a couple of things, and this will finish this up. It's a really pretty short section. So I want to just kind of look at these as true or false questions. So what I want to kind of look at on this is let's see what's happening at 448 degrees. Okay, well, first of all, if we take 448 degrees, and if we subtract off 360, because it's one more lap around the circle, we would end up having, it looks like, 88 degrees. Well, okay, looks like the teacher was clever and had that in mind. Okay, so here's the idea. If you have an 88 degree angle, okay, without a doubt, the sign of 88 is going to be positive because it's in quadrant 1, and everything's positive in quadrant 1. Okay, well, if you did a 448 degree angle, all it means is it's one lap around the circle, then it's 88 more, so it's going to be the same answer because it's still a quadrant 1 angle. So the sign of 448 is going to be positive, so that means the answer to that problem is going to be true. Okay. Okay, the next one, let's maybe convert these to degrees. Okay, so if we do this, that would be 180 over 6. So that's a 30 degree angle. And then this we're going to do 7 times 180 over 6. 180 over 6 is 30, so 7 times 30 is 210 degrees. So what we're going to do is we're going to compare these two things. We're going to look at the cosine of 30 degrees. We're not going to crunch it out. We just care about what the sine is. Then we're going to look at the cosine of 210 degrees. Okay. So first of all, if you did this, a 30 degree angle is in quadrant 1. Everything's positive in quadrant 1. So that answer is going to be positive. If you look at a 210 degree angle, that's going to take you to quadrant 3. So we would have to find a reference angle for that. So if we did 210 minus 180, now that's the reference angle, like that. Okay, so the only thing is we got to figure out, do you get a negative or positive value out of that? Okay, it's 30 degrees. Okay, like that. So either the answer to this problem is going to be the same or it's going to be off by a negative. Well, the thing is, remember the cosine's definition is x over r, and if you're in quadrant 3, x is negative, and then r is positive. So that means you're going to get a negative answer. So that means the answer to this problem is going to be false. Okay, so I'll pull up my calculator again on this, and I'll show that. You don't want to do these problems on your calculator because you're trying to learn how to think, and that's like incredibly important. There's a lot of stuff in trig you can do on your calculator, but if you do that, you're going to learn the concept. So if I do cosine 30, notice I get this, but if I do the cosine of 210, I will get the same numerical value, but it'll be negative because of the quadrant it's in. Okay, so that's what you want to get from that. Okay, let's look at this last one here and see what we can figure out on this. So what I'm going to do is just convert these things to degrees because it's a little bit easier to see. So 180 divided by 9 is actually 20. So 4 times 20 is 80 degrees. So we're going to be looking at the sine of 80 degrees. That's a quadrant 1 angle. Without a doubt, that's going to give you a positive value. Okay. So now, well, let's do this. Negative 22 times 180 over 9. 180 over 9 is 20. And then if I do 20 times 22, let's pull out my trusty calculator here. So if I do 22 times 20, I'm going to get 440. So this is going to be negative 440 degrees. So what we're going to be looking at on this is we're going to be looking at the sine of negative 440 degrees. Okay, so let's draw a picture of that. Okay, and again, this is clockwise. So, and it's more than one lap around the circle. So if you went from there to there, that of course is negative 360. So if we did negative 440, and if we just added 360 to that, what you're going to end up with is negative 80 degrees. So what this means is you go clockwise, but then you go 80 degrees more into this quadrant, like this. So it means that you have that 80 degree reference angle right there. Okay, So the idea is, okay, the sine of 80 is quadrant 1. So that's positive. Okay, now this one ended up being in quadrant 4. And since the sine's y over r, if you're in quadrant 4, y is negative, r is positive, so you get a negative value. So that is not going to have the same value because it's in a different quadrant where the sine has a different sign. So the answer to that problem is going to be false. Okay. And again, if you just check this on a calculator, look what happens. If I do the sine of 80, I get this value. If I do the sine of negative 440, okay, I get the same numeric value, but it's off by a negative. So what we're trying to show you on this is all these principles that we're really trying to show here is that if you did the sine of some angle alpha, and if you did the sine of the reference angle that I'll call alpha prime, then either you're going to get the same answer or you're going to get a negative. You know, they're going to be off by a negative. So that's the idea of what those things are talking about. Okay, so that is the end of this section. It's a pretty short section, not too hard to learn. So hopefully this will help you to manage and understand the concepts in section 1.6. Hope you enjoyed the lesson. Have a good night.